skyscrapers. These towering giants are more than just structures. They are marvels of modern engineering and architecture. Towers of glass and steel. They stand as testaments to human ingenuity and our relentless pursuit to touch the sky. These buildings reach for the clouds, piercing the heavens with their sheer height and grandeur. They are the epitome of urban development. They define our city skylines, creating iconic silhouettes that are instantly recognizable. Each city has its unique skyline, a fingerprint of its architectural identity. Think about it. What's the first thing you picture when you hear New York City? Chicago? It's the skyscrapers, right? These towering structures are synonymous with the cities they inhabit. Skyscrapers are more than just buildings. They're symbols of ambition. They represent progress, innovation, and the human spirit's unyielding drive to overcome challenges. They house thousands of people, businesses, and dreams. Within their walls, lives unfold, companies grow, and dreams are realized. They are vertical cities in their own right. But building a skyscraper? That's a whole different ballgame. It requires meticulous planning, cutting-edge technology, and a workforce of skilled professionals. It's a massive challenge that pushes the limits of engineering and construction. Every detail, from the foundation to the pinnacle, must be executed with precision. It's about conquering the forces of nature, one steel beam and concrete pour at a time. The process is a symphony of coordination, strength, and resilience. Let's get our hands dirty and see how it's done. Join us as we delve into the fascinating world of skyscraper construction, where every beam and bolt tells a story of human achievement. You can't just stick a skyscraper anywhere. The ground has to be ready. Think of it like this: you wouldn't build a house on sand, would you? Skyscrapers need strong foundations. These buildings are heavy, really heavy. The foundation distributes that weight. It prevents the building from sinking or tipping over. Engineers carefully study the soil. They dig deep. Sometimes they have to go down hundreds of feet. They hit bedrock, that's the strong stuff. Then they pour concrete. Lots and lots of concrete. This creates a solid base. It's the platform for everything that comes next. Skyscrapers aren't made of bricks like those old buildings. They need a skeleton. A really strong skeleton. That's where steel comes in. Steel is strong, it's flexible, it can handle a lot of weight. Perfect for a skyscraper, right? Think of the steel beams as giant Legos. They are bolted and welded together. This creates a grid-like structure. It's the backbone of the skyscraper. This steel frame supports the entire weight of the building. It transfers the load down to the foundation. It's what allows these buildings to reach for the sky. Ever felt the wind push you around? Imagine what it does to a skyscraper. Wind is a big problem for tall buildings. It can cause them to sway. It can even make them vibrate. That's why skyscrapers are designed to dance with the wind. Engineers use computer models. They test different shapes. They figure out how to minimize the wind's impact. Some skyscrapers have tapered shapes, others have curves or openings. These designs help to disrupt the wind flow. They keep the building stable and safe. Section 5: Earth-shaking challenges. Building for seismic zones. In regions where the ground can suddenly shift and shake, constructing buildings that can withstand these forces is crucial. Engineers and architects must work together to design structures that can endure the unpredictable nature of earthquakes. Earthquakes can turn a city into rubble. The devastation can be immense, with buildings collapsing, roads cracking, and essential services being disrupted. The aftermath often leaves communities struggling to rebuild and recover. Skyscrapers in earthquake-prone areas need extra protection. Engineers use special techniques to ensure these towering structures remain standing. This involves meticulous planning and innovative solutions to counteract the forces of nature. They make the buildings more resistant to ground shaking. Reinforcements are added to the foundation and the structure itself, providing additional strength and stability. This helps to minimize damage and maintain the integrity of the building during an earthquake. One way is to use base isolation systems. These systems are designed to decouple the building from the ground motion, allowing it to move independently of the shaking earth. These are giant shock absorbers. They play a critical role in absorbing and dissipating the energy generated by an earthquake, reducing the impact on the building. They sit beneath the building. Positioned between the building's foundation and its superstructure, these isolators act as a buffer, absorbing seismic waves and preventing them from causing significant damage. They absorb the energy of an earthquake. By taking in the energy, they reduce the amount of force that reaches the building, helping to keep it intact and safe. They prevent it from traveling up the structure. This means that the upper parts of the building experience less movement, reducing the risk of structural failure. Another way is to use flexible materials. These materials are designed to bend and flex rather than break, providing an additional layer of protection. These materials can bend and sway without breaking. This flexibility allows the building to move with the earthquake rather than resisting it, which can lead to less damage. They help the building move with the earthquake. By allowing for controlled movement, these materials help to dissipate the energy and reduce the overall stress on the structure. It's all about protecting people and property when the earth decides to move. The ultimate goal is to ensure that buildings remain safe and habitable, even after a significant seismic event, safeguarding lives and reducing economic losses. Section 6. A choreographer's touch, the role of the structural engineer. Building a skyscraper is like conducting an orchestra. You've got all these different parts, all these different players, and then you've got the conductor, the structural engineer. These are the brains behind the operation. They understand the science, they know the math, they turn architectural dreams into concrete realities. They use computer software. They do complex calculations. They make sure every beam, every column, every connection can handle the stress. They are the unsung heroes of every skyscraper. Section 7, from blueprint to reality construction, stage by stage. Building a skyscraper is a massive team effort. It takes years of planning and construction, hundreds, sometimes thousands of workers. It's a carefully choreographed dance of skilled trades. First, the foundation is laid, then the steel frame rises floor by floor, concrete is poured, facade panels are installed. Inside, electricians, plumbers, and HVAC technicians weave their magic. They install the building's vital systems. It's a complex ballet of cranes, welding torches, and hard hats, a testament to human ingenuity and collaboration. Section 8. Vertical communities, the inner workings of a skyscraper. Skyscrapers aren't just about steel and concrete, they're about people. They're vertical communities. Think about it. You've got offices, apartments, restaurants, even gyms all stacked on top of each other, and all these people need services. They need elevators, they need water, they need power, they need air conditioning. Skyscrapers have complex systems to provide these services. These systems are hidden behind the walls, but they're essential to keeping everything running smoothly. Section 9. Green Giants, Sustainability and Skyscraper Design. Skyscrapers are big, they use a lot of energy, but they don't have to be energy hogs. Architects and engineers are designing skyscrapers with sustainability in mind. They're using green building materials. They're incorporating energy-efficient systems. Some skyscrapers even generate their own power. They use solar panels or wind turbines. It's about reducing the building's environmental impact. Section 10. The future is up. Innovations shaping the skyline. The world of skyscrapers is always evolving. New technologies are emerging. New materials are being developed. We're seeing taller, more sustainable, and more innovative skyscrapers than ever before. Buildings that can adapt to their environment, buildings that can heal themselves, buildings that can even clean the air around them. The future of skyscrapers is limited only by our imagination. Section 11. Reaching for the clouds. The enduring allure of skyscrapers. Skyscrapers are more than just buildings. They are the epitome of human ingenuity and architectural prowess. These towering giants are a testament to our ability to overcome challenges and reach new heights, both literally and figuratively. They're symbols of human ambition. Each steel beam and glass panel is a piece of a larger puzzle, meticulously planned and executed to create structures that defy gravity and redefine skylines. They represent our desire to reach for the stars. The construction of a skyscraper is a complex dance of engineering, design, and sheer willpower. It's a process that involves countless hours of labor, precision, and coordination. From the Empire State Building to the Burj Khalifa, these iconic structures have become landmarks that define cities and captivate imaginations. They are not just buildings, they are symbols of progress and innovation. These towering structures inspire awe and wonder. They draw tourists from around the world, eager to witness the marvels of modern engineering. Each skyscraper tells a story of vision, determination, and the relentless pursuit of excellence. They remind us that anything is possible if we dare to dream big. Skyscrapers are a physical manifestation of our aspirations, a reminder that with enough effort and creativity, we can turn the impossible into reality. So the next time you see a skyscraper, take a moment to appreciate the incredible engineering and human ingenuity that made it possible. Think about the countless individuals who contributed to its creation, from architects and engineers to construction workers and planners. Behind every towering facade is a story of innovation, hard work, and the relentless pursuit of pushing the boundaries of what's possible. These structures are a testament to what we can achieve when we work together towards a common goal. Skyscrapers are more than just feats of engineering. They are monuments to human potential. They stand as beacons of what we can accomplish, inspiring future generations to dream bigger, reach higher, and build even greater wonders.